You got to know how it works. These are for double displacement reactions. Okay, so a double displacement reaction, I think a lot of you can identify, but a double displacement reaction would be one that you got two compounds that are together. And you got to determine if a reaction happens or not. So you can have no reactions on these as well. Okay? So this is a double displacement reaction is AB aqueous plus CD aqueous. And this A goes where C's at, and C goes where B's at. So then it becomes CB plus AD. So when we do these reactions, one of these two over here, depending upon how they combine, is going to be a solid. So one of these two will make this CB a solid and this is aqueous. Or we could have it the reverse of that. So for this reaction to happen, one of the products will form a solid. So the question is, how do we know if it's going to be a solid? How do we know if C, when it combines with B, is going to be a solid? How do you know that? Or how do you know when A goes with D, it's going to automatically be aqueous? That's what this chart is for. Okay? And to successfully use it, you've got to know what it means by soluble and what it means by insoluble. Okay, you guys can write on your chart if you want to. You don't have to. I'm just highlighting these two words. Okay? So, 1 and 2. There's no exceptions on 1 and 2. On 3 and 4, they say they have a thing called except. That means they won't be soluble when they're put in this situation. 5 and 6, you have 2 excepts. Except, like you guys have something, I remember when you spell something, I comes before except after. I before E. See, I before E except after C. Okay? So that's an exception, right? Hey, it's always this way except if it follows a C. Okay? So in chemistry, when we look at these solubility guidelines, we have this thing called soluble. Now, what it means by soluble is if you mix it up, it dissolves. And if it dissolves, it forms an aqueous solution, thus AQ. So anything that says AQ, that means you know it's soluble. Vice versa. If it's soluble, you write AQ. So let's look at the ones that are soluble. So what ions, now guys, I didn't have this for periods 1 and 3, so please don't write any more information down on that sheet. Okay? Because you're adding notes to that sheet that you can use, and you're not going to be able to do that. I'll have to give you another sheet. Does that make sense? They're just using the table, and they didn't write anything in. So like on a test or something, you're just going to get this sheet without any notes on it. Okay. So, what ions, so the stuff that I write, don't write. Okay? So, what ions are always soluble? Number 1. Sodium, potassium, ammonium. Okay? That would be, for example, we would say soluble, which is AQ, would be if I have Na, K, and NH4. So you're always going to write AQ. They are kind of like dominant genes. Like if you look at phenotypes, which are physical traits in genetics, a phenotype is dependent upon the dominant gene, right? If there's not a dominant gene present, then it's the recessive genes. Okay? So if these are present, what are you always going to write after the compound? AQ. Every single time. You see one of those three, you automatically write AQ. It doesn't matter what it's with. Behind it. Okay? Same with number 2. What do you look for? These are all soluble. So nitrates. Anybody know the formula of nitrate? NO3. Acetate. C2H3O2. And chlorate is ClO3. So guess what? If these are present in the formula on that product side over here, okay, so which one, if those 1 and 2, which one are we going to have? Is it going to be CB or AD, that combination? AD, right? If you have any of those in the formula of AD, like nitrates, chlorates, potassium, sodium, ammonium, they're all going to be AQ. They're all going to be right here. All of those ions are going to be, when they're together with something else, is going to be aqueous. Questions on that? Make sense? Now, let's go skip 3 and 4 and let's go to insoluble. So, insoluble. What are you going to write with it? So what's going to be in parentheses if it's insoluble? Solid. Okay, so you guys had some insoluble ones, right? I mean, when you put the drops together, they were formed insoluble. How do you know they were insoluble? Well, it formed a white solid or a yellow solid or whatever. Okay? So, these are insoluble. Carbonates. Phosphates. And silicates. Well, then how in the heck did I dissolve them if they were in solution? You say, well, if they're insoluble, then how did you get them to dissolve? Because I had to have them in a solution so that you could add the drops. What do you think I put those with so that you guys could test them? That's that exception. I put them with sodium, or I had a compound that had sodium with them, potassium with them, and ammonium with them. Do you guys see those over here? So if these are present, these are dominant. If sodium's with carbonate, it's soluble. If potassium's with silicate, it's soluble. It's aqueous. Okay? It's only when they're with those three that they're soluble. So that exception means, hey, they're soluble when they're with sodium, potassium, ammonium. Okay? Number 6. Guess what? Sulfides are pretty much insoluble most of the time. Okay. When aren't they soluble? Well, they add 2 things in. Other than these 3, they add in 2 things. Calcium and strontium. They say if calcium and strontium is with sulfur, then it's still soluble. Any questions with that? Okay, now 3 and 4, there's some exceptions on that. They say that 3 and 4, they say, you know what, most of the time a sulfate, or most of the time, number 3, chlorides are soluble. When are they solids? When they're with silver, mercury, and lead. They're called the heavy metals. Silver, mercury, and lead are heavy metals. So if I have PbCl2, that's a solid. If I have NaCl, that's aqueous because it's not one of those 3. And in number 4, it says most sulfates, that's SO4, they're insoluble, but there are 5 cases where they're considered insoluble. Okay, the exception is insoluble with barium, strontium, lead, calcium, and mercury. So we get the opportunity that I'm going to give you 8 of these combinations in a formula. And what you're going to do is use these rules And you're either going to determine they're soluble or insoluble based upon the statement. Okay? That's why you have to have your polyatomic ion sheet out so that you can... If you don't know what sulfate is, you can look it up. If you don't know what silicate is, you can look it up. Same with carbonate. So I'm going to give you 8 combinations. You need, just put this on a scratch sheet of paper. 8 combinations, and you're going to tell me, with those 8 combinations, if it's...
Are we turning it in?
No, you're not. This is just practice. Okay? So here's the combinations. All you have to do is just look them up and decide if they are just fill in the parentheses. Okay, so do those 4 or 8. Kind of maybe keep looking at it as we go through the first 3 or 4. Al2CO3, so it is insoluble, you think?
Yeah, all right.
Okay, well let's look at the insoluble rule, just to double check. So, most carbonates are insoluble, except if there was sodium, potassium, and ammonium. So that would be correct, right?
Yeah.
Would that be a solid? Okay.
Boom.
All right. We got 1 for 1 for you, Ava.
Yeah.
Second one. Na3PO4.
Soluble.
Soluble. So we write
AG.
AQ. Because of which one? Na. It's dominant. Na is always soluble. Sodium's always soluble. Nitrate's always soluble. Those except. Okay. So good. First 2. CAS. We look at the last rule. Sulfides are insoluble, except if they're with, calcium. So it's soluble. It's AQ. I know. But you got to see those exceptions. If you don't, and you have to do it, so that would be aqueous. How about CaSO4? Soluble, isn't it?
I thought it was insoluble.
Okay, let's look at SO4. Most sulfates are soluble, except if they're barium, strontium. So it should be insoluble, shouldn't it?
Yeah.
So that should be
An S.
an S.
No. I know, I'm pretty smart.
Does that make sense? We getting them? So let's go down through these. Potassium, it's aqueous. AgCl, it's one of those sections.
AQ.
Solid.
Oh.
Because when you look at chlorides, it says these chlorides are soluble unless they're with silver, lead, or mercury. You got to write a solid for it. Ammonium, it's in your first one. It's AQ. And then acetate, C2H3O2, AQ. Make sense?
Yeah.
Okay. Alright. Now, you guys have to give me 2 reactions because you guys will have to do 6. I'll do two with you. The first one I'll do for you. The second one you'll kind of do a little bit. We'll check your answer. And then I'm going to have you do 4 more reactions. So we transition from this to a reaction that happened in the lab. So give me a combination of solutions on this sheet that took place. So look on here to find out what reactions took place. What?
H2SO4.
Okay, so we got H2SO4, which is aqueous. So these are always going to be aqueous on the left side. What'd you put it with to form a solid? Okay, BaCl2. BaCl2. So what we're going to do, we'll do the double switch. H takes barium spot, and barium takes sulfate spot, or hydrogen spot. So it's BaSO4 plus HCl. Now, if you notice, I just wrote one of each. I'm not bringing this 2 subscript under H2 over. I'm not bringing the 2 from Cl over. I'm writing one of each. The only time I bring a subscript is if it's part of a polyatomic ion. Then I have to bring the whole thing over. Okay, next thing I do, second thing I need to do is I then make sure the charge is balanced. So I look at the charges. Guess what? They balance, so I don't need subscripts. The third thing I do is I have to determine which one of those is a solid. So you guys put in which one you think is a solid, based upon what we just did. So these would be like 2 problems that we just did, and you have to look at your sheet and see one of those have to be a solid if the reaction happened. Now if the reaction didn't happen, then they would both be aqueous, which would be your ones that would be clear.
So now we have to look at our sheet.
Yeah, you got to look at that bottom sheet and see the combination. Is it soluble? You write AQ. If it's insoluble, write an S. So you guys just do it, and we'll see if you're right.
Does both of the parentheses have to be the same?
No. Most of the time, one's going to be an S, the other one's going to be AQ. Most of the time. 90-some% of the time. Okay? So, which of these is an S?
The first one.
Yep, and then this is aqueous because it's got chlorine in it, and if chlorine's with silver, lead, or mercury, then it'd have to be a solid. So that would be, and the last thing you would do is what? Balance. So you just put a 2 in front of HCl. And you're done. Okay? Let's do a second one that does not include either one of these solutions. So give me a combination that reaction took place that does not involve one of those 2 solutions. Okay, AgNO3 and Na3PO4. Okay, you guys do the double switch, see if you get it right.
Then A3.
Na3PO4. You guys do the double switch.
How do we know which one is true?
Okay, after you do the double switch, check their charges. Silver's +1, nitrate's -1, sodium's +1, phosphate's -3. So on the right side, put them together correctly based upon their charges. So do the double switch. Make sure subscripts are used to balance charges out to get the right formula. That's some of you are not doing that right on the last quiz in here. So you guys start doing that, a better job of that. Once you do that, then you need to determine which of the two products is a solid and which one's aqueous. So after you write the formula correctly, you'll have to determine which one's solid, which one's aqueous.
Can they be like flipped around?
Yes. Yep. Yeah, the position doesn't matter. All right, which one's solid? Ag3PO4, right? And NaNO3 is aqueous. So then you balance it.
Oh.
So balance it.
Wait, what? Isn't NO3 insoluble?
Nope, it's soluble. Nitrates are always soluble. Sodiums are always soluble.
Yeah, you're right. Wait.
Steps 1 and 2 shows you that they're soluble.
Yeah, so then why is it?
Soluble means
I don't know
AQ.
Yeah, I missed that.
Yeah, sometimes people think the S stands for soluble. It doesn't.
Yeah,
It stands for solid, which is insoluble.
that's confusing.
So then you just put a 3 there and a 3 here, and it balances. So what I'm asking you to do for tomorrow is do 4 more examples.
Are you going to give us problems?
Your problems are on here. You pick out 4 combinations that reacted. You pick 4 combinations that happen. I did 2 for you. You're asked to do 4. So you're going to have to do those 4.
Okay.
Okay? And then we'll look at them tomorrow. I don't care what 4 you do.
Can we use the 2 from today so we only do 2 more? Do you want to?
No.
I didn't know.
Total is 6. You need to do more than 2 to get them down better. So
Yeah, so we will.
that's not too bad, is it?
No.
Okay.